Okay, so if there are no questions, so let's get started. So good morning, everyone. Thank you so much for coming again to the tutorial. So just an announcement that assignment 2 has been released. So it's due on March the 5th, which is around a month away from now. Again, assignment 2 is on data flow analysis. In today's tutorial, we'll be discussing about the programming portion of assignment 2. And in our next tutorial, which will be 2 weeks later, we'll be discussing about the theoretical questions of it, which is on lazy code motion. Okay. Anyone has any questions or concerns? Okay, so if there are no questions, let's get started. So in today's tutorial, we'll be discussing about the programming portion of assignment 2. In assignment 2, you will be asked to implement the data flow analysis framework that we have described in class. So specifically, your framework will look like the follows. It will accept the domain, the type for the domain element, the direction of your analysis, and your implementation, a definition of the meet operator. And what it has as a member is that so it will have, the framework will have its analyzed domain. It has a mapping that tries to map for each instruction, from each instruction to its corresponding domain values. And finally, it has this top-level function that says that runs on the entire function, similar to what you have in the function path. So this is the top-level method that we have, which is run on function. So how should your framework run on each single function? Well, the way we are going to do it is that so first, we are going to initialize the domain. As an example, in the case of available expressions analysis, to initialize domain, we'll start by capturing all the binary expressions in the function. So as we have mentioned before, in the scope of this course, we'll be only concerned with binary expressions. Okay. So when we are initializing the domain, we start by capturing all the expressions in the function. And after that, we'll be start by initializing the instruction to domain value mapping. So can anyone please tell me, how should we initialize the instruction to domain value mapping in the case of available expressions? Anyone? How should we do the initialization step? I mean, even if you don't want to answer it now, you still have to answer it when it comes to your programming assignment. How should we do the initialization step? So we initialize the instruction to domain values mapping by using the initial conditions, right? So what is the initial conditions in the case of available expressions? Does anyone still remember? What is the initial conditions? So the initial condition in the case of available expressions is given by the universal set, right? Okay, so now that we have finished initializing the domain and the instruction to domain value mapping, we therefore start by traversing through the CFG and update this mapping until the mapping has converged. So by converged, we mean that so after an entire traversal of the CFG, there is no change. There are no changes to the mapping. Okay. Does anyone have any questions regarding this high-level workflow? No questions? So from this high-level workflow, what methods do we have to implement? Well, clearly we have to implement inside the class, inside the framework class. We have to further implement this initialize domain method that initializes the domain, and also this traverse CFG method that keeps traversing through the CFG and updating the instruction to domain value mapping. And furthermore, we also need to implement the top method of our meet operator. Why do we have to implement the top method? Because the top method gives us the initial condition that we want to leverage to initialize the instruction to domain value mapping. Okay. Any questions? So if there are no questions, let us see how we should go and implement the traverse CFG method. Okay. So how are we going to traverse through the control flow graph? Well, suppose that we are given a function and the direction, of analysis. We start by traversing through all the basic blocks of this function. So could anyone please tell me what is the optimal traversal order, let's say for a forward direction analysis? I think we have described it in lecture. What is the optimal traversal order for forward data flow analysis? Anyone? Okay, maybe check back your lecture slides and figure out, so what is the optimal traversal order for the basic blocks? Okay. So if this basic block has no operands, has no meet operands, then this clearly implies that so we are at the boundary. In the case of forward analysis, this therefore implies that so we are at the entry of the function. So therefore, we get the initial condition, get the boundary condition as our initial value. Otherwise, if the meet operands are not empty, then we apply the meet operator. And after applying the meet operator, we get the value we get from the meet operator denoted as the initial value. We use the initial value as the input value. And for each instruction inside this basic block, what we are doing is so we apply the transfer function at each instruction. And after applying the transfer function, we assign the mapping of the new values to the input value. And this process keeps going on and on until we reaches the end of the basic block. So in the case of forward analysis, how should we traverse through the instruction of the program of a basic block? Anyone? This is a simple question. again, even if you don't want to answer it now, you still have to answer it when it comes to the actual programming assignment. So it's better to figure it out now. Or if you have any questions, ask them now. What should be the traversal order for the instruction in the case of forward analysis? Is it clear to everyone? This is not a hard question. Is it clear to everyone what the question is? How are we going to traverse through the instructions of a basic block? Suppose you have this method, get instructions traversal order, that you have to implement. How are you going to implement this method that accepts a basic block? Is this that hard to answer? Anyway, so maybe try to figure this out at home or later on. So let us continue. So therefore, from okay, sorry. So from this traverse through CFG method, we can clearly see that. So we have to implement the following. So we have to implement inside the framework class the boundary condition method and the meet operands method that gives, for each basic block, gives us the meet operands. And outside of this framework class, what we will have to implement is the call method. So for anyone who doesn't know, this operator here is similar to the call method implementation inside Python. So we have to implement the call method of the meet operator and also the transfer function for each child class that we have. Now, going back to the frameworks that we have, from this description, we can clearly see, so starting from this top level method run on function, what we will want to implement, we will have to define the following method. We have to define the method that initializes the domain. Again, so in the case of available expressions, each initialized domain grabs all the binary expressions in the program. We have to implement this method that traverses through the CFG and update the instruction to domain value mapping. We have to define this boundary condition, which in most cases is just the null set. And the method that for each basic block, given a basic block, grabs all its meet operands. And finally, the transfer functions that every child class has to implement. So as you can see, the transfer function here is marked as abstract method. The reason is because every child class needs to implement this transfer function. Anyone has any questions? I mean, if you have any questions or confusions, please ask now. So let's go to a more specific. Okay, so in the previous case, we talked about this transfer function, which is marked as an abstract method. So therefore, every child class that inherits from the framework need to implement the transfer function. So how should this be done? So let us take available expressions as an example. In the case of available expressions, again, so hopefully everyone still remember from our tutorial 2 weeks ago, or from your assignment 1, that the domain of analysis in the case of available expressions is expressions. Okay. And we are going to, and in the framework, we are going to represent whether an expression is available at a certain point using a single Boolean value. So that is, so we use false to indicate that it is not available at the program point, and 1 to indicate it is available. Available expressions is a forward analysis. Okay. And the meet operator of the available expressions is the intersection. Okay. So for hopefully our students remembers that the reason is because we require that the expression is available if it is evaluated on every program path, starting from the entry until that program point. Okay. And available expressions, therefore, needs to define the transfer function. Okay. And hopefully everyone still remembers that the transfer function of the available expressions involves the gen set and the q set of it. And we further need to define this intersect meet operator. Okay. And inside this intersect meet operator, we further need to define two methods of it. So one is the call method that tries to merge two bit vectors together. As you can probably imagine, this is a very simple AND operation. And the top method, which given the domain size, return the top element. As we have discussed previously, the top method is used to initialize the instruction to domain value mapping. So how should the top method be implemented in this case? Anyone? How should you do the initialization in the case of available expressions? We just talked about it. So how should we go and implement this meet operator? Well, as we have described before, so in the meet operator, we are given a basic block. So what we will have to do is that we will start by getting all its meet operands. So let us take forward analysis as an example. So suppose that we have this basic block BB. How are we going to get the meet operands of it? What is the meet operands in the case of forward analysis? Anyone?
Is it intersect?
I mean, intersect. So your answer is right in the sense. So intersect is the meet operation. So we are talking about the meet operands. So what is the meet operands here?
If it's the start, I guess it would be the universal set, or?
No. That is the initial condition. The universal set is the initial condition. It is initial condition. So let me write its full name to avoid any confusion. If we want to get the meet operands, in the case of forward analysis, we'll be getting all the predecessors of this basic block. Right? So the predecessors of the basic block defines the meet operands. Is this clear to everyone? Because this is forward analysis, right? So the predecessors define the meet operands. And after we get the meet operands, we apply the intersect as the meet operation. Is this clear?
Yep.
Again, so to avoid it, in the case, okay, so in the case when the meet operands is empty, when meet operands is empty, this means that we are at the boundary, then therefore in those cases, we apply the boundary condition BC. So let us return back. As we have discussed, in the case of forward analysis, what we will be doing is that we first start by getting all the meet operands of the basic block, which is defined as the predecessors of the basic block here. And after that, we get the final instruction of all the predecessors, which is denoted as here, the back. So the back here denotes the final instruction. Okay, and after that, we get from the instruction to domain value mapping all the corresponding domain values from the basic block, from the predecessors of the current basic block. And finally, we apply the meet operator, which in the case of available expressions is intersection. Is this clear to everyone?
Yeah.
Okay, so finally, we'll have to discuss about, so how should we go and implement the transfer function of available expressions? In the case of transfer function, what we are given is that we are given the current instruction to be analyzed. the input bit vector, and we have to output the output bit vector, and furthermore, whether the output bit vector has been modified or not. Again, so as we have described, in bit vector, each bit is used to denote whether an expression is available at a certain point. So how should we go and implement this method? So let me return back to the Blackboard. So suppose that we have this expression, let's say C is equals to A plus B. Okay, so assume that this is our instruction to be analyzed. This instruction clearly generates the expression A plus B. Therefore, what we'll have to do is that inside the bit vector, we'll have to set, imagine that the input bit vector is something 0 here, where this 0 here denotes expression B plus C. Oh, sorry, A plus B. What we want to do here is that we want to set this bit to 1 to denote that the expression becomes available after this instruction. Furthermore, we can further observe that this instruction kills any expression related to C. Okay, so assume that there is the expression, let's say C plus A before. The expression is killed after this instruction. Okay, and therefore assume that in the bit vector mapping, we have something like 1 in this case. That 1, we have to unset that bit to 0 to denote that it is no longer available after the instruction. Is this clear how the transfer function is implemented? So specifically, the bit vector is used to represent whether for each instruction, whether each instruction, not each instruction, but whether each expression is available at a certain program point, where 1 denotes available and 0 denotes it's not. And what we want to do inside the transfer function is that so we want to set the corresponding bit to 1 if the expression is generated, and to 0 if the expression is killed. Is it clear to everyone what we are trying to do here?
Just a question, how is the vector mapped to each expression?
That's a very good question. So the mapping, you're free to define any mapping so long as the mapping is consistent throughout your analysis. Okay, so as an example here, so let me keep this. Assume that we have this bit vector 0, 0, 0. Assume that we have this 3-bit vector 0, 0, 0. And we use, let's say assume that the first 0 denotes expression A plus B. The second 0 denotes expression B plus C. The third zero denotes expression A plus C. You are free to switch any order. Let's say I want the first bit to denote B plus C instead. It's fine, it's perfectly fine. You're free to switch the order of it. So long as this entire thing, the entire mapping, this mapping here is consistent throughout your analysis. Is it clear?
Yeah, wouldn't you just do it in the order that the expressions appear in your program?
Yeah, sure, that's one way to do it.
Okay.
I mean, again, you can, when you try to initialize your domain, you can gather the expressions as they appear in your program. Sure, that's one way to do it. But I mean, so what I mean is that, you can use any order you like, so long as the order is consistent throughout your analysis.
Okay.
Because when you have a consistent order, when you say that, so when you see this zero, you know exactly that. So okay, so this expression B plus C is not available as this program point. Any other questions? Or does this answer your question?
It does. I was also wondering, like, would it be like a dictionary type, like a map key?
Yeah,
Key value?
another way of implementing it. So you can have an extra, say, mapping that maps from expressions, binary expressions, to, let's say, indices. So the size T here denotes indices. For each expression is corresponding indices. Yes, you can have an extra mapping for that.
Okay.
Other questions? If there are no questions, let us return back to our definition of the transfer function in the case of available expressions. How are we going to define the transfer function? Well, let us first consider the Q set, okay? For each element inside the domain, i.e., so for each expression in our program, for each binary expression in our program, if, let's say, the left-hand side of the expression is equal to the current variable, or the right-hand side is equal to the current variable. In the examples that we wrote on the blackboard, this therefore denotes, so if the left-hand side is equal to C, or the right-hand side is equal to C. This means that this expression, as an example, C plus A, falls into the Q set. And what we want to do, therefore, is to set its corresponding bit to false. This is on queuing the expression. And what about generating the expression? Well, to generate the expression, we first start by finding the expression inside the domain. In this case, we'll be finding the expression A plus B inside the domain. And after locating the expression, what we want to do is that we want to set its corresponding bit to true. That is, we want to set the bit that corresponds to expression A plus B to true, to 1 here. Is this clear to everyone about the Q and the gen? This is just what we have described previously. And finally, we want to check whether the output bit vector has been modified or not, because we need this information to tell us whether the mapping has converged or not. Okay. Okay, so let us first going back to what we have described today. Okay. So in today's tutorial, we start by discussing about the implementation. So how are we going to implement this iterative framework of our data flow analysis? Okay, so we start by saying that, okay, so we want to implement this run on method, run on function, top level method. And from this method, we said that so inside this run on function, we have to start by initializing the domain, which is given by the initialize domain method. And after the initialization, we keep going traversing through the CFG until no changes have been made to the instruction to bit vector, instruction to domain value mapping. Okay. So when traversing through the CFG, what we want to do is that we have to traverse through all the basic blocks of the function. Again, so check back to the lecture slides for the optimal traversal order in the case of forward and backward data flow analysis. Okay. So to traverse through the CFG, we start by traversing through all the basic blocks of the all the basic blocks of the function. Okay. For each basic block, we start by checking its meet operands. In the case of forward analysis, the meet operands are given by the predecessors of the current basic block. In the case when the meet operands are empty, we apply the boundary condition, okay, given by the method BC. After getting the boundary value of the current basic block, we start by applying the transfer function at each instruction. Okay. And in the case of available expressions, we have described, so how are we going to implement this transfer function, which is so to set certain bit and to unset certain bit in the bit vector mapping. And furthermore, we have also needs to implement the intersection bit operation. We have to further implement this intersection bit operation for the available expressions analysis. Okay, where its call operator is to simply add two bit vectors together, and its top method. Again, so what should be the top method inside for the intersection meet operator? Anyone still remember? What should be the top? How should we implement the top method? So let me ask it in another way. So how are we going to initialize the instruction to domain value mapping? I think your colleague has mentioned it. What is the initial conditions here? The colleague has mentioned that the initial conditions in the case of available expressions is given by the universal set. Okay. And we further know that so this initial condition is also the top value of the semi-lattice. Okay. So therefore, how are we going to implement this top method here? What should we return in the top method? Anyone? Is the question clear? So how are you going to implement, like this top method is exactly the same as your initial conditions. So now that you know that the initial condition is the universal set, what should you return in the form of beta vector in the case of top method?
Shouldn't it be just a vector of all ones? Because
Yes,
all the
exactly. Exactly. Is it clear to everyone? Why you should get a vector of all ones? Anyone has any questions about the framework and also our example on the available expressions? If you have any questions, please ask now. Because we do not have tutorials 1 week later, I think. So it will be a public holiday. Or if you are confused with anything and want an explanation, please ask as well. I think we still have around 5 minutes time. Any questions? Okay, so if there are no questions, that's all I have for today. And your homework assignment for today is to implement the available expression and liveness analysis of assignment 2. Okay. Thanks, everyone.